Good morning, and this is Vinod from Talent Next Gen. The session is all about big data. So big data is working with huge volume of data, right? So today I'm going to take a half an hour of session, giving you a impressive idea on what is big data and what are the technologies used in big data, so that there will be a kind of interest for you in learning big data. Yeah. Uh, to start with, I'm an architect and I work with an MNC for 15.5 years. Did quite a lot of designs on big data and platform as a service. So in these learnings, I found that big data is quite easy to learn. I want to make that easy learning to you guys, and from there you can take up some trainings and catapult your career further. Okay. So the website has been given to you. You can go and browse the talent.co.in and get an extensive idea on what is big data. So getting into big data, everybody have a question: what is big data? Yeah. So usually, being an engineering grad, everyone have a answer. Big data is big data. Okay. Um, if you want to go and attend an interview, or you need to know what is big data. Yeah, so there are some V's, 4 V's are there in big data. I'll get through that in the slide. But on a layman's perspective, I want to give you a small overview on it. You can see a data growth that has happened from last 10 years, from 2005 to 2015, and progressive until 2019. Yeah. The x-axis is the year, and the y-axis is in zettabytes. Okay, so you see that in 2005, less than 1 zettabyte, 2006, 1 zettabyte, 2007, 2. So it is exponentially growing year on year. By the time 2015, we are around 12 zettabytes of data. So that's the growth that's happening uh, uh, within the system. From where does this data come from? In those days, the only source of data is more towards through data entries, through computer systems, some banking transactions. Yeah, but nowadays your mobile phones, all the GPS devices, sensors, DNA, and all this are giving chunks and chunks of data getting inside the system, and data is growing year on year in zettabytes. So in 2019, we may reach 40 zettabytes. So that's the potential. So there was an era about mobile era, right? Mobile technology is going to boom. Then it became cloud era. So it's going to be all cloud technology going to boom. Now it's going to be big data era. So it's going to be more big data related stuff are going to get a boom. And for next 5 to 10 years or 15 years down the line, it's all going to be big data and big data related jobs. Yeah. So this particular section is going to tell you like from where are we getting this huge volume of data. Yeah. So like the transactions that's happening across the globe, like the credit card transactions, internet transactions, eBay transactions. Yeah. Kind of enterprise data. Enterprise data is like the data that's been churned out by the organizations and big MNCs. Public data, something like the data that is coming from public source like Google Drive and other informations, government announcers, some publishings or some news materials. Sensor data, yeah, there are a lot of heat sensors and other sensors are constantly providing information into the system. So sensor data, social media, that's one of the volume of data coming from internet is Facebook, the number of likes and number of Facebook updates happening on the wall, the tweets that are happening, the LinkedIn updates. Every time, every millisecond or every second, a huge volume of data is being running inside the system. Yeah. So big data is a mix of all this, and it's very tough to analyze or get the right information from this data. Okay. From architecture point of view, what I would say is data I can classify into two forms. One is periodic data. Periodic data is something like the data is getting accumulated and kept stored in one location, like a database, so that you can go and pass them. Some are real-time data, like sensor data is a real-time data. A sensor says there is a heat, or there's overheat, or there is a fire that needs to be immediately responded to. So we should have some method to quickly analyze those real-time data. So some are periodic data, some are real-time data. Hadoop is a periodic data based big data element. And if somebody asks you like, can Hadoop handle real-time data? The answer is no. There is a tool or there's a new technology called Impala which can handle real-time data. So that's one of the interview tip for you guys. Periodic data can be handled by Hadoop, but not real-time data. For real-time data, we need Impala. Yeah, good. So four V's of big data. If you know all these four V's, then you're pretty much done with big data. Okay. Volume. You know what the volume of data that's happening, right? Every day, lot of transactions, lot of tweets, lot of Facebook updates and sensor data. So these are the information that are getting accumulated and getting stored in one place, like in a storage or data center or Google Drive or drives. So terabytes or to exabytes of existing data are there. So whenever you search something on Google, Google goes out and search on those periodic data that's been stored, the volume of data that's been stored. So it's not that easy to get a filter or analyze the data and get what you need. Yeah, right. So Google uses the big data technology to do a search engine for you. Velocity is data in motion. That means that the data is continuously streaming, and every milliseconds to seconds there are a lot of inputs happening, and within milliseconds you have to respond back. Take an example like somebody is doing a credit card transaction, and that transaction has to go to the server, update, reduce the balance before he makes the next transaction. Otherwise, if it takes few seconds, the frauders would have made another transaction of another 1 lakh, and there's no way of catching him. So velocity is the speed in which the data comes, the streams of data that comes in per second, per millisecond is what the velocity of information that you need to handle. Varieties means the different styles or different forms of data. You take a data which can be a audio file, it can be a video file, it can be a text file, it can be different forms, right? So even when you search something on Google, Google is able to make out whether it's a PDF or an image or from audio file. From it can analyze all these different varieties of information and can gather input to you. Yeah. And veracity is the data in doubt. It's more like there's uncertainty, like some data will come off way and it doesn't go through the entire uh, path. Before that we need to analyze and we have to get that rolling. Yes, that becomes the data in doubt. These are the major four V's of big data that one should be aware of and one should work on. Yeah. So volume, velocity, variety, and veracity are the four elements. So the problem with big data is what I'm going to suggest next, and we'll get to there and see how what are big data problems that it poses and how are we going to overcome. Yeah. So problem statement in big data. If we are following the traditional method, one second, there seems to be a small issue in streaming. So just okay, fine. Fine. So the problem statement. In traditional method, like you imagine a database which has rows and columns and unique fields, so that if somebody asks about a particular student information and what is his marks and max, it's like a rows and columns. We can do some search and we can filter out those data because that's more of structured. But in big data environment, they are not structured; they are unstructured. There are different varieties of data. The data is moving, and the data is also in doubt, so they are not in proper order. If that is the case, how can a standard database handle that situation? Yeah. So in that case, we have to go with a big data approach. Yeah. So in traditional approach is something like the data. When I want to search about a particular student and student related information, the entire set of data is moved to the compute, and the compute will start parsing that data, find the right match, and it filters and gives it to you. But when it comes to big data, that's not possible because of the volume, because of the variety, because of the velocity. So multiple compute will go to the data. So the difference between traditional and big data is in traditional approach, data is, data will go to the compute, but in big data approach, compute will go to the data, segregate the data by using a technology called map reduce, and it will create some maps, and it tries to find which is the right data that I'm looking for, and it gives me those output. so which is much faster. Traditional approach, it will take hours and years to get to that result, whereas big data will get me quick updates using this technology. Yeah. So in this training, we are going to see how this Hadoop cluster works, the basic building elements. Yeah, so clients are people like us who are going to Google to do some searching or do some data processing. So the two elements that major building blocks of Hadoop is the map reduce element and the HDFS. Yeah, map reduce is something like creating some maps and reducing the data into some smaller chunks, and HDFS is distributing the data and making multiple copies of it, so that if even one node fails, we can fetch the data from the other area, and distributing the data across multiple nodes for quicker processing. Okay, so MapReduce uses job tracker and task tracker kind of stuff. So the job tracker is something like it assigns a job to one of the node, and that node will create some maps. Task tracker are something like when you assign a task for something like search or do some analytics, then the task is assigned to that node, and that node will take a load of work and it will start processing. So the key elements are MapReduce and HDFS, and some of the nodes are name node and the data node. Name node are the server nodes, and data nodes are the clients which are going to be participating in that Hadoop cluster. And we can have a number of data nodes that's unlimited. So they are called slaves. Masters, we have name node and secondary name node as a fallback mechanism. Yeah. So in this short span, what I'm going to do is I'm going to touch base on what is MapReduce, what is HDFS. So let me start with MapReduce, and that's one of the interesting and classic element. I want to use a real-time example to show you how MapReduce work, and from there you can kickstart your world of big data and how MapReduce works. Yeah. Oh, I hope you would have all played cards. Yeah, playing cards. So I just put out a set of playing cards out there. We have 52 cards, right? So cards are having multiple colors, multiple symbols, and multiple numerals. Yeah. So we have 52 set of cards, and we have two colors, black and red, and we have A, two, three, four kind of cards, and clover, spade, hearts, and diamonds. Okay. So the person who is sitting below, the person wants to pick up a card called King of Diamonds. Okay, and just imagine if I take them up and K of diamond is in the last, and this person works like more like a computer. So each card he will flip and see whether it is K of diamonds. So if it take 1 second for him to flip a card and find whether it's K of diamond, when he flip the first card, no, it's not K of diamond. The second card, third card, fourth card. So it takes 52 seconds for him to find the K of diamonds, right? So this is a traditional way when the data is big. At the moment, it's not big, but you take it that it's big. And for acquiring each card, it takes 1 second. For K of Diamond, it takes 52 seconds to find that card. Okay. So how big data does is, first let me make the mapping. First, the map is map them as black and red. Okay, so when I map them as black and red, now those cards have become 26 and 26 cards. So black cards like spades and clover on the top, and heart and diamond. So I have two players there, and I ask these players, whenever I say I want K of diamond, first I know that diamond is red, so I go to the diamond card person and I'll ask, I want K of diamond. Now he starts flipping each card. When he flips each card, it takes 1 second. So until he gets to the K of diamond, it takes roughly 26 seconds. So just doing mapping, and instead of one person, one compute, I made two computes. My speed is doubled, right? So I am able to find my search much quicker. Now, if instead of two persons, if I go for four persons, I'm trying to reduce it. So I have four different players, and each of them are given with 13 sets of cards. And I ask them like, for clever, for if I say black, first I go to that guy. If I say red, I go to that two guys. And if I go for the symbol diamond, then I go for this last person who's sitting with the diamond symbol. I go to him and ask K of diamond. He will flip each card by card. It takes 13 seconds for him to get his card. We make further reduce, like I say, alphabets like A, J, Q, K as one set, and 2, 3, 4 numerals as one set, and it would be less than 4 seconds to find K of diamond for this guy. So more the maps, more the reduce, I am able to easily get to that card quickly. So these individual guys are called the data nodes, and these guys carry the information about the data and mapping about the data. And the name node is the person to whom I submit a request. I want key of diamond. He knows which map, which person holding that information. I asked him. He goes and search out for me on the actual data, fetches me the right information. I think this is a classic example for showing you what is map reduce. Yeah, I hope that's an interesting session for you, and you love what MapReduce is. A lot of tools and techniques the developers that use. Probably this would be a starting point for them. With this basic core foundation knowledge, they can get to that kind of expertise. Okay, the second element is HDFS, Hadoop Distributed File System. Actually, this was a Google distributed file system or Google file system, which Hadoop got through Apache license. And we'll see what the basic structure is. Like it has name node, secondary name node. So name node and secondary name node are the master servers who will receive the query from the clients. Yeah. And secondary name node is an HA, high availability node. Even when the main node fails, that will take care of the failures. So you see that data nodes are being connected via dotted lines where there's a lot of heartbeats. And you know what a heartbeat is? Heartbeat is like checking the availability of their nodes. So even the node fails, it will go ahead and fail over the information to the next node. Load balancing is something like when one particular node has been overloaded and that load has been shared with the next node and so on and so forth, so that the search or analytics is more quicker. Replication is like on the data node you see some set of colors. You see that one particular color is been between three different nodes. For instance, you take black is on the node number 2, node number 3, and node number 5. If you take green on node number 1, node number 4, and node number 5, so that the data, the same set of data is being put on three different nodes as well, so that the availability of that particular node, even if one node crashes, that particular data is not being discarded, and the other node can process it. Yeah. And the data nodes have the job tracker and task tracker stuff. So job tracker takes care of the map reducing activity, and task tracker takes care of taking the user input and getting the task executed, producing a search or producing an analytics for you guys, and provides you the output. So nodes have a local disk where it can keep a local copy of it, of the actual data. So it's a high level overview of HDFS. Once you get into the training, each component is split into further small pieces, and they will be explaining you about how to set up this HDFS environment and how to make this heartbeats, balancing, and replication, etc., etc., etc. So the main core elements of these two elements, like the MapReduce and HDFS, are covered. I hope the session is more interesting, and the time is for asking questions. You guys can ask me questions on the queries you have, and this is the address that's where the training is going to happen, and the session is going to start there. Yeah, so open for Q&A. If you guys have any questions, you can ask questions. Those people who are very hesitant in asking questions can type their questions on the chat window, and I'll take up those questions and I'll respond to it. Open for Q&A. Okay. Yeah, I got one question. Like the question is like, what are the job roles for big admin, big data admin? Okay, you want to know about big data admin, or I'll tell you what are the major roles. One is big data administrator. The role of this big data administrator is to set up the environment. For that, the guy should have basic Linux experience, and he should know how to install Linux, how to install the Hadoop softwares, the big data softwares, configure the clusters, setting up services, yeah, and see the end-to-end operations of the Hadoop cluster and make it running, like a kind of operations role. Yeah, so anyone with Linux experience and basic networking and hardware experience can get into big data administrator. And I always say that even the big data developer or data scientist, whoever it is, they should have big data admin experience. That's a mandatory skill that I feel would be a stepping stone or a foundation part. Yeah. The second part is the big data developer. Big data developer is a person who works on multiple projects of big data. Like big data is not a single tool or single software. Big data uses Hive, Pig, and a lot of other projects, yeah, which are used for multiple other purposes, like for database, NoSQLs, and other stuff. So they are available as open source, but based on customer requirement, you need to reprogram it or make some customization changes, develop a new tool to work in big data to get this information processed. So there are a lot of opportunities for big data developers. So that's area for them. And data scientists, big data scientists are the people who have the visualizing skills, who are going to do analytics, who are going to have the insights onto data and capture informations, produce optimal information for something. So the word is something like um, uh, the data can be without information, yeah, but the information without data doesn't make any sense. So that's one of the word I have read somewhere. So there can be data without information. So those data are something like encrypted or secret stuff. But if you have an information without any data, that doesn't have any validity, right? So big data is going to do that part. It's going to produce a set of data for your information and gives or adds value to information. So that's where the big data scientists or analytics or insights persons are going to get. These are some of the major roles, major designations that most of the companies provide. Okay. Yeah. Okay. The second question is more like, does Google uses big data? Oh, not just Google. Nowadays, all each and every top guys, even the small companies, have started doing the big data. One classic example would be like even the Google search. Yeah, Google search uses a technology called Google Bubble. Kind of like you search Egypt and I search Egypt, or somebody else search Egypt. All of us doesn't get the same Google search result. The reason is like Google creates a bubble for each individuals, and it tracks, for instance, like a person like me, where I'm a constant traveler and I travel different countries and I log in from different systems. Google Bubble creates a profile for me saying that we know this a person is a frequent traveler. When I search for Egypt, it shows me what are the best hotels in Egypt, what are the best sightseeing places in Egypt. It's more about commercial things for me, what I can buy in Egypt and where I can see in Egypt. But when it searches for another person who is not a constant traveler, he is there in Chennai for a long time and he constantly uses one system to log in and work. So Google creates a profile that is not a constant traveler. And probably in his last previous search, he was searching for some history related stuff. So Egypt, when he searches, he gets only about Egyptian mummies, about pyramids, who are the king, who are pharaohs who worked on Egypt. So those information, so that's called Google Bubble. So that's the kind of analytics, like search and get what that person want is what the big data. Big data is a kind of thing which creates and gives you fruitful information to your need. So that's what it does. So Google search is one classic example for it. Okay. Okay, very good question. Like, do we need to have a very big setup for setting up a big data? No, definitely not. If you have, that's better. But you are aware about Cloudera and Hotter Networks. They provide a sandbox VMs. Those VMs can be imported inside your laptop if you have sufficient 2 GB, 4 GB RAM, and roughly 100 GB of disk. You can host that VM inside your laptop and trigger a big data kind of environment, and you can start using your development on that, and you can take out the tool out and put it on the real big data environment. So you need not have a big setup to do that. Normally in training centers and other trainings, Hadoop sandbox and Cloudera sandboxes are being used to do it. And don't worry about the setup. As I told you, big data is not one small tool. Big data is a collection of different projects and different elements. So there are some installers which are readily available from Cloudera and Hotter Networks. We can use them, customize it through a configuration file, and based on that, we can get the HDFS and other environment setup uh, kind of fully automated. Yeah? So it's not rocket science. It's all about making things much easier. If you want to really make a customized environment, then we need to know about each step line by line to get that information down. Yeah. So I don't find any more questions on this. Yeah. So I hope this session is quite interesting, and within the short span of time, I was offered to just 15 to 20 minutes. I roughly crossed over 25 30 minutes now. Yeah, so keeping a check on the time, we can definitely meet someday when so once you turn out here. Yeah, we can have a very big insight about MapReduce and HDFS and big data, and we all become data scientists. Yeah, so wish you all the best, and I wish you a very great career. Thank you. Bye bye.